Hi, everyone. My name is Andrea, and I'm a content marketing specialist here at Vultr. In today's Tech Talk, we are going to discuss and learn how to build continuous integration and development pipelines by leveraging easy to use GitHub Actions and Vultr Kubernetes engine. Watch the Tech Talk now.
Hi everyone, my name is Mridul Soru and I'm a developer advocate here at Vultr. In this tech talk, we are going to be discussing how to create CI/CD pipelines using GitHub Actions and Vultr Kubernetes engine. Continuous integration and continuous deployment significantly enhances the software development lifecycle by allowing developers to integrate code changes regularly. CI/CD creates a streamlined and collaborative development approach. One of its primary advantages is early detection of errors. Through automated testing, issues are identified quickly, reducing complexity and the cost of fixing problems. This immediate feedback loop not only ensures software quality but also fosters an agile development approach. Moreover, CI/CD automates the deployment process, eliminating manual errors and accelerating the delivery of software in many environments. This automation enhances efficiency by promoting consistency and reliability in the deployment process. GitHub Actions, a robust feature embedded within the GitHub platform, empowers developers to automate workflows within their repositories, and they can be made by simply creating a YAML configuration file. It serves as an integral tool for the CI/CD pipeline, enabling the automation of various tasks directly tied to code repositories. When combined with Vultr Kubernetes engine, GitHub Actions becomes a more potent ally, and by integrating Vultr Kubernetes engine with GitHub Actions, developers can enhance the deployment and management of applications and benefit from the feature of GitHub Actions at no cost. In the next slide, we have Mayank with us who will be creating a CI/CD pipeline in a completely new GitHub repository.
Hi everyone, my name is Mayank and I'm the head of developer advocacy here at Vultr. And in this demonstration, I'm going to show you how to create a CI/CD pipeline using GitHub Actions and the Vultr Kubernetes engine. In the demonstration for continuous integration, we are going to apply applications unit tests to make sure it works with the rest of the code base. And to apply the changes using continuous deployment, we are going to build a container image and roll out a restart on our Vultr Kubernetes engine cluster. So let's get started with the demonstration. The first step of this demonstration is to create a new repository. However, you can reproduce these steps for your existing repositories by adjusting the configurations according to your structure. So for the example repository here, I'll just type in example CI/CD that's available and I'll set it to private repository and click on create. Now that we have a repository, I should be able to just go to my terminal and just make it a bit larger and use the GitHub CLI tool, which is GH, and type in repo clone and the name of the repository, which is Mayank Vulcheron example CI/CD. It clones the repository into this folder, which also says CI/CD demo, but you'll notice that there is a reference folder here. I'll just open that reference folder into VS Code and just pull it here. And you see there are some files. So this is a really small code base of a fast API application, which really just says hello world. And it also has some unit tests, not some, it's just a single unit test which checks if the request is responding with the 200 status code and the message is in fact hello world, and if we change the response it should fail. And then we have bunch of other configurations here for Terraform and Kubernetes, which we are going to dig deep into in the later part of this video. But for now, you can see there is a pyproject.tuml file because we initiated this with poetry. And then we have a script to check if the imports are correct, if the code formatting is correct, and lastly, if all the unit tests are passing. Because ideally, there would be more than one test harness, and the endpoint will not just say hello world. So, in idle scenario, there will be many endpoints and many tests. But this structure is just to replicate a real world use case. So we'll just copy all of these files. We'll also go through the Docker file in just a bit. I'll just go back to my terminal. I'll just open a repo folder into VS Code as well, and then paste these files. By opening a terminal here, I can just press Control and the tilde symbol. And on my local environment, I already have a package for poetry. I can check the version, but if you don't already have it, or you might not be using poetry at all, or you might not be using Python at all, this just for a general idea. If you want to use the same code base and you don't have poetry, you can just type in pip install poetry and you should be good to go. So poetry uses this file just to install all the requirements for the project, and we can do that by typing in poetry install. And now that we have all the dependencies installed into a folder, we can type in poetry shell to enter the virtual environment, and then type in uvcon, which is the ASCII web server, our app terminator, and app target. And let's just try to open it on a web browser. And you see that the message says hello world. We can also try to run the test. So we'll run the test script here by typing in dot slash test, and it runs the ISOT check, the black check, and then it checks for the unit tests if they are passing or not. Just to verify this, we can go to the endpoint and we can change it to say something like hello from Vultr. If you run the tests again, it should break and give you a assertion error. That's no good. So we'll undo these changes and we should be good to go again. Now that we know we have somewhat an ideal structure for our example code base here and the unit tests are working, we can break it by changing the response of this endpoint. We can go to the reference directory again. I'll just collapse this, close this file here, and go to the reference directory. You'll see I have two more directories here, which is GitHub workflows and then configs, which has the definitions for Kubernetes and Terraform. So the GitHub workflows configuration is a YAML definition. It has all the instructions for running out the actual procedure of continuously checking the integration and deployment of the code. So the name of this procedure is production perform CI/CD, and then it runs on commits. When there is a new commit on the main branch, you push to the main branch, and that's when the jobs will kick in. The first job is test. It uses Ubuntu latest. That's the image that GitHub is going to use for spinning up a container. It should have Python 3.10. And the step says that we need to check out the repository so that we have access to the repository files inside the container, and pip install poetry so that we have the poetry package manager inside the container, install the requirements, and the name of the step is test, which of course means we are going to run and the script that we had here, which checks for ISOT, black, and the unit tests. After we clear the test job, we also have a job which is currently commented out because we are going to implement it before, uh, which we should do right away. Instead of talking, I can just show you how it works. So I'll just stage all of these files and I'll just send it named initial commit. Let's just do that. So it's been a few minutes after I have pushed the commit onto the GitHub repository. We can hop onto that, and if I refresh this, you'll see there is a yellow dot here, which turned into a green check mark. If we go to the details, you'll see that it is running a job, which is the test job, and the steps are exactly the same as we evidenced in the configuration file, which is the checkout, then pip install poetry. Poetry is installing all the requirements, and then it is running the unit test. Uh, we can see if it is actually working by intentionally breaking it. Let's just go to the example app file and let's change hello world from vulture. All right. So let's just intentionally break it in and just breaking tests. Uh, I'll sync the changes just by adding a configuration in your GitHub repository. You can easily get the access to GitHub Actions. It's absolutely free to use, and it works really great with the Vultr Kubernetes engine. And as you can see, as soon as I've pushed the commit, it shows a yellow dot, which means the tests are in progress. And you see that it failed this time. And you click on it, it says that it returned hello from Vultr and it expected a hello world. So let's just fix the tests. Let's go to the test file. Instead of changing back the route, let's change the test itself, and let's just say fixed unit tests. Let's push that commit, and again, if you come to actions, you see the actions are already running. You click on it, you can see all the jobs happening in real time, and that's how easy it is. And we have already done half the things by achieving a CI part of the CI/CD pipeline, because it's testing if the changes are continuously being able to integrate with the rest of our code base. Uh, so yeah, let's go back to the workflow file. You can see deploy here. This is actually the reference folder. We can go back to the actual folder. Uh, it says deploy. Oops. Yeah, let's collapse this and deploy. It uses the same container image, which is Ubuntu latest. It needs the test job to run successfully. If it fails, deployment will fail as well. And then it uses the registry. This is GitHub uh, container registry. If you really want some performance, you should bring your container registry closer to your cloud resources and use something like Vultr Container Registry, which is super secure, super easy to set up. I'm just using GitHub Container Registry to make it easier for you guys to follow. So we can also just uncomment this part and show you this live in action. I'll just say enable Docker containerization. Uh, let's do that. Let's sync the changes. And this time round, you will see if you go to actions, uh, it will it will run the tests, but then it will not just stop there, but it will also build the Docker container, which uses this Docker file, which just does the same steps. Pip install poetry, import the pyproject.tml file, install all the requirements by running poetry install, and add all the files. So unit tests are done. Go to deploy. It's spinning up the containers, and it starts to build the Docker image right away. As you can see, the deploy step or the deploy job was also executed successfully. If you go back to the repository, you'll see a new package here, and this is the GitHub container registry. You can just pull this. You need to have your GitHub set up as a Docker login, but you can do that. We'll do that in Kubernetes by setting up the container registry secrets and use that to pull the image. But you'll see that it created a new container image and used the main tag, which resonates with the branch that we were pushing our code into. Now that we have achieved the CI part, and we are also doing some partial CD part because we have built the Docker image, we have pushed it onto the GitHub container registry. You see it there on the screen. Uh, let's go back to the reference folder, and let's copy the configs folder onto our repository here. There's nothing related to the workflow, like it will not automatically apply. You still have to go through some manual procedure just to get everything in order. After that, when you push new commits, it will just maintain your state as you want it to. So here is the Terraform definition. This is a provider definition for Terraform. This just downloads the official Vultr Terraform provider. And then there is a different file for the resource definition, which programmatically spins up a Kubernetes cluster, which is the Vultr Kubernetes engine. It's a managed Kubernetes cluster with Vultr CCM, CSI. So you can use Vultr block storage as your persistent volume claims, and you can use Vultr load balancers with Vultr CCM to use something like Nginx ingress controller, or exposing your HTTP TCP applications onto the internet. So here you see we have the region. This specifically is SJC, which is Silicon Valley, and then the label of the Kubernetes cluster, then the version, and for the node pool, I've went with the quantity of 3 nodes with this specific plan. For getting the plans, you can go to api.vultr.com/v2/plans, and you can put it into a JSON linter, or you have something like Postman on your system, or you can also make a script to find your perfect plan. So you see the ID, the vGPU count. Actually, it's the vCPU count, and then there is RAM, disk, and all. So you just choose the perfect plan for you and just put it into your Terraform configuration here. And the way it works is you need to confirm if you have Terraform in your system. I'll just do Terraform version. Actually, we don't need to be in the uh, poetry thing now. So let's just deactivate and clear this. And let's export vulture underscore API underscore key. So the question is, how do you get a vulture API key? You can go back to your web browser and log in to the Vultr customer portal. Here you can go to accounts page and access the API section. You can easily enable the API access and manage the access control. You just make sure that your IP is allowed to make requests. I've already enabled that for any IPv4 or IPv6 IP, and I'll just copy this key into my clipboard and paste it onto here. Don't worry about it, I'll revoke this key when the video goes live. Uh, After we have done this, we can just type in Terraform plan. Uh, Before that, we need to run Terraform init so that you can actually install the Terraform provider. So I was actually in a wrong directory and just got a little excited there. So we are in the correct directory now. I'll type in Terraform init. The package provider does not have available release for this. There seems to be some problem. Let's type in Vultr Terraform. Let's see what is the latest version. All right, let's get that one instead. Now that we have the Terraform provider installed onto a system, we can type in Terraform plan, which I accidentally run before we initialize the Terraform directory. Silly me. So we can just type in plan and it will show what changes is going to happen with your Vultr account. So this is just creation of a new Kubernetes cluster. It will show you what resources Terraform is going to spin up. So it says Vultr Kubernetes, then example CI/CD KTS will be created and the definition. To apply this, we can do Terraform apply and just type in yes. It will start creating that onto your Vultr account. We can go to products, click on Kubernetes. You can also see the nodes here, but you go on to Kubernetes and you see the cluster is currently being installed. Meanwhile, let's just go back to the Kubernetes folder and see that there are three configuration files that we have here. The first one, of course, is the namespace. We will get example CI/CD for containing the app deployment, which will follow a rolling update strategy, so that we are only unavailable for 20%, and we'll use two replicas. Just name it app in the example CI/CD namespace, and we are going to use the GitHub container registry, my Vultr on this image, and how we are going to pull it is by having a GHCR secrets secret resource in our Kubernetes cluster in that namespace. And then, because we don't have an entry point in our Docker file, we are going to have a command in the container which says poetry run unicorn, which binds the web server with 0.0.0 and it creates the workers using the UVCon worker class. And then we also have a short deployment of an internal service which exposes the access to the pods for app, so that we can interact with it from ingress, from a load balancer, or something like that. So it's just a cluster IP resource here. Then we also have an ingress resource. In order to use this, you need to install Nginx ingress controller, and then for the host as well, you need to add the A record of the underlying load balancer into the DNS settings. I'll leave that part out of this video so that it is very easy to follow through. for you guys. But yes, we can do that easily in matter of minutes. So now that we have a Kubernetes cluster and we have the configuration, the part which is left is we'll just download the configuration from here. We'll try to open it in VS Code. I'll just copy it and let's just go back to our GitHub repository here for a second. And let's just visit the settings page and you will see there is a secrets option here. When you go on to actions, here you have option to add a GitHub action secret. What a secret does is you don't want to add your Kubernetes manifest file as as a plain text file into your repository, because then every single contributor would be able to log into your K8s cluster, which is not what you want, because then they'll be able to bring your deployment down as well. So to avoid that situation, you can just create a repository secret and just paste in here, and we can just call it cube underscore config. Let's just add that. And when we need it, we can just access it by typing in an alias, which is secrets.kubeconfig. After you set up the GitHub repository secrets, you need to make sure that you have installed Nginx Ingress Controller, you have installed GHCR secrets, and you have also set up the DNS records, which are out of scope for this demonstration because it will make the demonstration even longer. So let's just go back to our repo directory and let's apply these three manifest files that we discussed about earlier, which are the namespace, the app deployment, and the ingress resource. So let's just type in kubectl apply the namespace. Let's also apply the app deployment. And when we try to get the pods in the namespace, you'll see that they are already running and it's only been 9 seconds. So that's pretty quick. Let's also apply the ingress configuration. And after we do that, it should mean that if we open the host name, it should say hello from Vultr. Now, what we can do is go back to our workflow file and we can uncomment this since we have the kubeconfig secrets now, and it will run the command in the namespace example CI/CD rollout restart deployment app, which will just restart the pods to get the latest version of the container images. So let's just do that. And to reflect the changes, I'll also do hello from Vultr. Let's do automatically uh, and make sure that we also take care of the CI part by making sure the tests are happy. Uh, let's not forget about this and automatic rollout, sync the changes. And now let's see the repository. Let's go back, see the yellow dot. Here you can see the rollout restart step was executed. And what that means is if you go back to your Kubernetes cluster and you type in get pods in the namespace, you'll see that the containers are running on the brand new container image, and you can also confirm that by typing in rollout history, the name of the deployment, which is app, and then the namespace. And you can see that there is this revision, and you can further go deep down by giving it revision 2, and then it will give you all the details that it restarted at this, which is the current time, and that's how you're able to send automatic deployments. So let's just refresh this page, and it should say hello from Vultr automatically. And that's it. We have implemented a CI/CD pipeline which helps us to push out the code automatically. Not only that, but it creates a barrier so that all the code which is being pushed onto the repository is well tested, well formatted with help of ISOT and Black, and then the unit tests, of course. Uh, After the tests are passed, it goes on to building the container image using the Docker file. And lastly, it sends a rollout restart to the Vultr Kubernetes engine, which will pull the latest container image. Thank you for sticking around through the demonstration. I hope you liked it. And that's how you can replicate this environment for your setup as well within minutes.